Hey guys, how's it going? Wanted to take a second to kind of walk everyone through the friction quiz you guys took last week. Obviously, your grades are in, but you haven't gotten to see solutions, so I thought I'd kind of show that for you guys and talk about maybe a couple like common mistakes that were made, and see if I can help troubleshoot some of that stuff in the future. So, first off, obviously the scenario was done right over there. My daughter, and we put her in a little Tupperware container and slid her down the steps. And so the free body diagram of that looks like this. We have an object on an incline, and we have this frictional force this way, right? We have a normal force this way, and the weight down this way. And then I'm going to draw my FGY and draw FGX. Now, a couple of things I noticed. A good number of people put an applied force on that. One, that doesn't make any sense. Two, it made it impossible to solve the problem. So it was a little weird that people put an applied force there and then really never used or referred to that applied force later on in their formulas. I think that concerns me because, one, it shows a huge lack of understanding of what we're doing in terms of if we're not using our free body diagram to create our formulas, then either one, we have no clue what's going on, we're just memorizing, or two, we're cheating. And neither of those are great options. You're not learning physics in either case, which is ultimately kind of what I care about. So a little discouraging to see a lot of applied forces there, and then to see those applied forces not be used later in our formulas really shows an even greater lack of understanding of what's going on. So remember, applied forces only exist when some external object is actually applying a force to push or pull. I just held her at the top of the stairs and let go. She slid down because of gravity. So there's our free body diagram. The weight we need to find. The weight, or Fg, is equal to mass times gravity. So we multiplied the mass of 14 kilograms times 9.81, and we get a weight of, I believe, 137 newtons. Okay, some given information we know. We know the distance down the steps is 5.2 meters, right? We know the time it took her to get down was 2.3 seconds. The angle is 40 degrees. Those are some important things we probably need to know. And of course, the mass, you have that. All right, so that's part B. The other part of B was we had to find the components. So FGX and FGY, that's Fagux and Fagui. FGX is the adjacent side. Sorry, FGY is the adjacent side, so that's the cosine. And FGX is the opposite side of our angle right here. So it's sine, and we end up, for FGX and FGY, we end up with 88.1 newtons and 105 newtons. As you continue to do things like this, submit them to me, please, please, please circle your answers. Make sure you have the correct units on them. All that's really important to help me grade. Please do not leave an answer without a unit unless it's mu, which doesn't have units. All right, part C. Most people did a great job with part C. We were asked to find the acceleration. And I gave you a hint. I said, please use one of your motion equations to do that. And the correct one is this one. Delta x is equal to VIT plus 1/2 AT squared. There's the motion equation you're looking at right there. When we plug numbers in, this term goes to 0. So we have a delta x of 5.2 equals 0 plus 1/2. A is, we're trying to find that, and t is 2.3 squared. And we end up with an acceleration of 1.97 meters per second squared. Something to be careful about. Depending on how you drew your picture, that number might be positive or it might be negative. There were some issues people had in part E with their math because they didn't have things in the right direction and they added when they should have subtracted, did some bad math, and that hurt them later on. All right. Part D wants you to find the normal force. So we're going to sum the forces in the y direction and set them equal to 0 here. When I look in the y direction, we have one force up, which is Fn, minus one force down, Fgy, and that has to equal 0. Remember, we found Fgy and Fgx, so this guy didn't matter anymore. We got rid of him. Okay, so Fn is equal to Fgy, meaning Fn is actually 105 newtons. Okay, really nice job there. A lot of people did great with that. Part E was where the most of the mistakes came from. All right, let's see if we can set part E. I have a giant piece of PVC pipe, literally just holding this board up here. It kind of gets in the way when I want to write, but we're just going to make do. So we're going to do E over here. E wants to know what the frictional force is. Okay, in order to find that, we're going to sum our forces in the y direction, or in the x. So we sum our forces in the x direction and set them equal to m times ax. And here's where the majority of you really made a huge mistake. All right, you wrote out this equation and said, okay, we have forward Fgx minus backwards, oops, need to erase, minus backwards friction is equal to, drum roll please, you put a big fat 0 there. And that was a huge mistake. This object is not in equilibrium. In fact, in part C right above, you guys solved for the acceleration of the object. So there was a huge mental disconnect there. I don't know if one person did it and just started sending it around in a big text chain and everyone decided, oh, this is good. I have no clue what's going on. We're going to copy this down. But it was completely nonsensical in terms of understanding what you had done so far up to this point in the problem, all right, to then say that's equal to 0. Because we're not in equilibrium. We are accelerating down those steps because this Fgx ends up being a bigger force than friction, which is why we started from rest and got going faster and faster and faster. So instead of 0, we have to put an ma over here, okay? Now, when we have this equation, we plug in our numbers, we plug in Fgx, we plug in Ff, we plug in the mass of 14, and we solve for a frictional force of 60.5 newtons, okay? And that was where a lot of people had some issues. And again, it's a tough place to go wrong because it really means that we're still struggling with some of the fundamental understanding of how these problems work, of what Newton's second law means, that forces cause acceleration. You accelerate, it's caused by a force and based on a mass. That's F equals ma all the way. And so we have to understand equilibrium, what it looks like and what it means. Last part, F, is we're trying to find mu. So that's simply the funnest formula in physics, where the force of friction is equal to mu times the normal force. We'll throw in the normal force we have here and the frictional force we have there, and we should get a mu of, I got around 0.57, 0.576 maybe, somewhere around there. That just depends on your rounding. So that's kind of your solution of the quiz. Again, big errors were some of the weird applied forces that I saw in there. And again, the tremendous amount of disconnect between my free body diagram with my applied force and then a summation equation that didn't have that force anywhere in it. And I don't really know how to do force problems without, to be honest, without taking a free body diagram, being able to look at it, and then write an equation based off our diagram. The same thing's true for equilibrium. We have an object accelerating down the ramp. We can't have forces cancel out when we're accelerating. That just doesn't make sense. So being able to understand the underlying concepts, and then, yeah, there's some math here. But if we know the physics and understand the physics, the math actually ends up not being nearly as hard or nearly as difficult. So there are those solutions for you. I hope that helps. Enjoy those. I will, catch you next time. I'm sure I'll be on in a little bit to do some more videos.